Alright. Okay.
Yes, we are going to do some revisions on the chemical basis of life, and we are going to start with the chemical principles. Let us first look at the elements. The elements. All living things on Earth are composed of fundamental building block of matter called elements. Right? More than 100 elements are known to exist, including some made by scientists. An element is a substance that cannot be decomposed by chemical means. An element is a substance that cannot be decomposed by chemical means. That is the definition of an element. An example of these are oxygen, iron, calcium, sodium, hydrogen, carbon, nitrogen. There are so many of them, and this one could be seen in your table of elements. If you get hold of any standard chemistry textbook, you will see it on the first page or on the last page. So, and I want everybody to make sure you have a copy of that one, written by your own writing, where you will state the atomic number, the molecular weight, and the symbol of each element, so that you can get used to it. Right? Now, an atom is the smallest part of an element that can enter into combination with atom of other elements. Right? Now, atom is the smallest part of an element which can enter into what? Chemical combination with another element. Atom of another element, right? And these atoms, what are they? They are protons,
electrons,
which is positively charged, electrons, which are negatively charged, and neutrons, which are neutrally, which have no charge. They are neutral. Okay? Proton and neutron adhere tightly to form the dent. And what is the dent? Positively charged nucleus of the atom. Okay? Electron spins around the nucleus, as I've just explained now. The arrangement of electrons in an atom play an essential role in the chemistry of the atom. Atoms are most stable when their outer shells of electrons have a full quota. There are several shells in an electron, in an atom, right? But starting from the inside, that inside has two. That's the inside shell has two. Then the one following it has 8, right? And so on, and so on, and so on, right? The first electron shell has a maximum of 2 electrons. The second and all other outer shells have a maximum of 8 electrons. Sometimes you can have up to 16. In fact, what they want to say here is anything that can be divided or that can be divided by 8. Sometimes it is 16, sometimes it is 32, and sometimes it is 64. Okay? Now, atoms tend to gain or lose electrons until their outer shells have a stable arrangement. The gaining or losing of electrons or the sharing of electrons contribute to the chemical reaction in which an atom participates. As I was saying, if two atoms want to join together, if at the end of the joining, the atoms, the both atom A, atom B, If the outermost shells are not complete, that reaction will not take place. Okay? But once the reaction will complete, that one will be spontaneous. Right? It will be spontaneous. Okay? Of course, you can have negatively charged particles in the body. You can also have positively charged particles in the body where they are forced together to join together. Okay? Now, let's see what we call molecules. Most of the compounds of interest to biologists are composed of units called molecules. A molecule is a precise arrangement of atoms of different elements, and a compound may be a collection of molecules. The arrangement of the atom in a molecule accounts for the properties of a compound. This is very, very important, and it's very, very basic. The molecular weight is equal to the atomic weight of the atom in the molecule. For example, the molecular weight of water is 18, right? Is 18. If you check the molecular weight of oxygen is 16, and that of hydrogen is 1. Because we have 2 of hydrogen joining to 1 oxygen, then you have 18. So by the time you get that something, you will know everything very well. The atom in but oxygen gas is not a compound, as I told you, because if they want to be stable, that atomous shell must be completed. So two oxygen can join together. 2 oxygen can just join together to be stable. 2 hydrogen can also join together to be stable, and that's why you have hydrogen gas, oxygen gas. They are not really a compound, because a compound contains 2 or more elements. Right? So the atom of a molecule may be joined to one another by various linkage called bonds. Right? Atom may be joined together, and the linkage is called bond. One example of bond is an ionic bond. An ionic bond is formed when the electron of one atom transfers to the second atom. Right? Like when the atom of hydrogen is transferred to that of oxygen, we have ionic bonding between oxygen and hydrogen. Okay? The same thing in ammonia, when nitrogen atom combines with hydrogen as 3 hydrogen atoms this time around. 3. 1, 2, 3. Right? We now have ionic bonding between nitrogen and hydrogen. Okay? Right. An ionic bond is formed between the electron of one atom transferred to the second. This creates electrically charged atom called ions, right? As I just explained. The electrical charges cause the ions to be attracted to one another, and the attraction forms the ionic bond. Any question? Anybody who is not too clear? Right. A second type of linkage is called covalent bond. Is covalent bond. When you say covalent bond, let's see the difference between the ionic bonding and the covalent bonding. Right? A covalent bond forms when 2 atoms share 1 or more electrons with one another. For example, oxygen shares an electron with 2 hydrogen atoms, and the resulting molecule is water. Right? Nitrogen shares an electron with 3 hydrogen atoms, and the resulting molecule is ammonia. If one pair of electrons is shared, the bond is single bond. If 2 pairs is shared, it is then a double bond. Right? It is then a double bond, as I've just explained. If you share, in fact, this is how it is sharing oxygen here. Right? This is how it's shared. If 2 oxygen combine together before you get oxygen gas, this is how it is. It is like this. Because the first one has 6 anyway. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right? So when they share together, this one will be having 1, 2, 3, 4, 5, 6, 7, 8. Right? 1, 2, 3, 4, 5, 6, 7, 8. So they will be stable. You see the trick? That's what they do. They will be stable. So the combination of two oxygen atoms to form the oxygen gas is double bonding. Okay? It's double bonding. Okay? So that's an example of double bonding I just given to you. Now, let's get to acid and basic. Acid and basic. Now, the certain chemical compounds release hydrogen ion. When the compounds are placed in water, these compounds are called acids. Right? These compounds are called acids. For example, when hydrogen chloride is placed in water, it releases hydrogen ion and the solution becomes hydrochloric acid. When you place hydrogen chloride in water, it will release its hydrogen into the water, and the solution will become what? Hydrochloric acid. Right. That is, well, let's just see. I'll give you another definition of an acid. Certain chemical compounds attract hydrogen atoms when they are placed in water. These substances are called bases. Right? An example of a base is sodium hydroxide, NaOH. When this substance is placed in water, it attracts hydrogen ion, and a basic or alkaline solution results as hydroxyl ion accumulate. Right? Now, when an acid, when a substance that can donate protons is called acid. They can donate their proton. You know, the proton is in the nucleus here, isn't it? Yes. So now they can donate their proton. They don't care. They just donate it. Right? Such substances are called acid. Yes. There are some substances that can affect protons. If substances affect protons, they are called bases or alkaline. That's one definition. That is David Lawrence definition. There are so many definitions for acid and bases. Okay, but just take that one. The other one are talking about electrons. Right? The other ones are talking about electrons. Right? That if some will say if any substance that can affect electrons is called acid. Anyone that can donate is called basic. So it's opposite sign.
The alkaline is in the human body, right?
We have a part in the body where it is alkaline. Yes. And we have parts in the body where it is acid. Yes. So now let us see organic compounds. The chemical compounds of living things are known as organic compounds because of their association with organisms. Organic compounds, which are the compounds associated with life process, are the subject matter of the organic chemistry. Now, I will always ask you, what are organic compounds? And the answer is any compound that contains carbon atom. Any compound that contains carbon atom is called organic compound. Any compound that contains carbon atom is called organic compound. Okay? Now, we are going to some of the compounds that contain carbon atoms. And I told they are called organic compounds. The first one we are going to check or to see here is the carbohydrate. Who can tell me what the significance of carbohydrate is like? Yes? That, and that's what they give what? Energy. In form of what? Glucose, and the glucose is breaking down into what?
Monosaccharide. ATP, adenosine triphosphate. I've taught you in this class. Okay? Among the numerous types of organic compounds, 4 major categories are found in living things, in all living things. The first category is the carbohydrates. Carbohydrates are used by almost all organisms as sources of energy. In addition, some carbohydrates serve as structural material. Carbohydrates are molecules composed of carbon, hydrogen, and oxygen. The ratio of hydrogen atom to oxygen atom is 2 to 1. Now, we are told here some carbohydrates. We said carbohydrates are source of energy, number 1. We now say carbohydrates are also used as a structural element. In what do we use carbohydrates as structural element? Yes? We have cellulose cell wall. You know cellulose is also carbohydrate. You know that? This cellulose. So we have cellulose cell walls in all plants, don't we? Yes. And cellulose cell wall, that is the thing that actually makes the leaf to stand erect, isn't it? If there is no cellulose cell wall, they will just fall like that. You know the animal cell does not have cellulose cell wall. We have, but it's only the plant, and that's what is serving as their structural element, like the skeleton in the body, right? So, a simple carbohydrates are commonly referred to as sugar. That is the simple word. Sugar are the monosaccharides if they are composed of single molecule, or disaccharide if they are composed of 2 molecules. Please note that. The most important monosaccharide is glucose. Monosaccharide, glucose, right? And why are they called monosaccharide? Because in glucose you have glucose joined to glucose joined to glucose joined to glucose to form monosaccharide. Okay? The most important, right? A carbohydrate with the molecular formula C6H12 H12O6. As we have said, the ratio of carbon to hydrogen is what? Hydrogen to oxygen is what? Ratio 2 to 1. So this one will be CH12O6. Okay? That is ratio 2 to 1. It's 1 to 1. Okay? Glucose is the basic form of fuel in living things. It is soluble and is transported by blood fluid to all cells. I've told you this before. Where it is metabolized to release its energy. Glucose is the starting material for cellular respiration
and it is the main product of photosynthesis. Right? Three important disaccharides are also found in living things. One disaccharide is maltose. Maltose, a combination of two glucose units covalently linked. Another disaccharide is sucrose, the table sugar formed by linking glucose to another monosaccharide called fructose. Right? Then a third disaccharide is lactose, composed of glucose and galactose units. Okay, please take note of all this so that you will actually see it. When you see it, you will know it. Now here we have the monosaccharide and the disaccharide. Right? We have the monosaccharide and the disaccharide. So we can see the glucose, fructose, and the fructose. What I'm trying to say is the structural formula. COH, C. So you must know this. This is very important. Then you must tell me the difference between the glucose, fructose, and sucrose. Right? Glucose and fructose are monosaccharides. When these two join together, they are called disaccharides. Okay? Glucose and fructose molecules combine to form the disaccharide sucrose. In the synthesis, a water molecule is produced. The process is therefore called dehydration. The reverse of the process is hydrolysis, a process in which the molecule is split and the elements of water are added. Okay, elements of water are added. Now, let us see, we've seen the mono, we've seen the di, the two. Now let us see the polysaccharide. That is a very complex one where many of them are joined together, so that you actually know what you have been seeing all these days and they look so important to you now.